This course shows you how to implement just enough instructions to run a Hello World example. We'll start with a program written in regular C code that we will compile as a bare metal application using the standard Linux C and C++ compiler, GCC. Then we'll use the GCC linker to produce an executable and linkable format, ELF file, that we will finally disassemble to create a list of assembly instructions that we must implement to run the program. Next, we'll load the program into block RAM in the FPGA, which will function as the program memory. We will create a decoder module for decoding the instruction words, an arithmetic logic unit for performing numerical operations, and a control unit for executing each instruction. Finally, we implement the design on the FPGA to run the Hello World program and see the output printed to the serial terminal on our computer. Let's open the helloworld.c file, which is the source file for all of the other files in this folder. So I have generated the other files from this program. This is a C program. We can see the main function here, which is where the program starts. First we call uartprint and supply the string hello world. And these are the operations that we can extract from this list. Actually, I have added 2 more operations that are not on the list. One operation and one that's not an operation. We can start with the one here, NOP, no operation. That's an operation, it is not present in the list here, but I want to have this here because then when we initialize the signal, it will have the default value no operation. So that's a good idea to have. Then the next value, unknown, is a special meta value I've invented, instruction not recognized by decoder. So if we get an instruction that the decoder can't handle, we will set this value on the operation output, and the control unit will have to deal with that or produce an error, whatever we choose. Now that we have created the supporting modules, we can proceed to implement the main module of the RISC-V processor, which is the control unit. The control unit is the module that actually executes the instructions. It gets the instructions from the decoder and executes them by talking to the ALU and to the memory. It can read and write from the memory, and it will update a program counter which points to the next instruction in the memory so that it can be output to the decoder, and the decoder can send it back to the control unit. And the control unit is also the module that talks to the outside world, outside of the RISC-V processor, through the UART interface. We're going to implement BNE, which is branch if not equal, and branch if equal in this lesson because they are quite similar. So let's go to the PDF for the RISC-V specification and look at page number 40, which covers conditional branches. It says here that all branch instructions use the B type instruction format, and this is important because then we have to use the B immediate. And then we have to go through all of the folders that have VHDL files in our project. Top RT, wrapper, the CPU, select them all, and there we see it. Then we can click program device. The bit file should already be filled in and hit program. And now the FPGA will be programmed, and immediately when the reset is released, it will start running our program, the instructions that we have loaded into the memory. But we can't see anything going on the board except the LED has illuminated. And that's the LED that I set to 1 in the top level wrapper. However, if we go to a serial terminal, for example like this one, YAT is the name of this program, yet another terminal. If you want to use a different serial terminal program, you can do that, but I will link to this one from below the video. So we see it has printed out hello world, which is great. And now the program is running in the while loop.